Hello students, I am Ashish De. I am taking one of your subject, that is digital signal processing. In my earlier video, I have discussed about bilinear transformation method of designing FIR filter and explain that method with an example. In this video, I want to discuss about the design of FIR filter using window. Now, what is window? You have to learn that, and why we are interested to use window techniques. Okay, so when now design of FIR filter using window. We know the desired frequency response is capital HD e to the power j omega. This is periodic in frequency and it can be expanded in Fourier series by using the formula HD n. Okay, so it can be expanded in Fourier series by using this formula n equal to minus infinity to infinity HD n into e to the power minus j omega n. Okay, now what is HDN? That is desired impulse response of the filter. Now this should be in finite duration, okay, for FIR filter. So what is the formula to obtain HDN from HD e to the power j omega? That is the inverse Fourier transform formula 1 by 2 pi minus integration over minus pi to pi HD e to the power j omega into e to the power j omega n d omega. So this is the formula of getting Laplace impulse response, desired impulse response HDN. Now this impulse response obtained by using this formula is of finite length. Now one possible way of obtaining FIR filter is to truncate the infinite Fourier series at n equal to plus minus n minus 1 by 2. Okay, where capital N is the length of desired sequence. Okay, it has already been explained in the previous video. But abrupt truncation of the Fourier series result in oscillation in the passband and stopband. These oscillations are due to slow convergence of the Fourier series, and this effect is known as Gibbs phenomenon. So Gibbs phenomenon. So what is Gibbs phenomenon? When we are truncating the infinite duration sequence, suppose this is the infinite duration sequence and we are just truncating the sequence to get it a finite value minus n minus 1 by 2 to n minus 1 by 2. So that will be in finite duration. Okay, but abrupt truncation of this Fourier series results in oscillation in passband. Suppose we are interested to design a low pass filter, then there will be some oscillation like this in the passband and stop band also. So these are the oscillations in passband. So this is the passband and this is stop band. Now this oscillation occurs due to the slow convergence of the Fourier series. Okay, and this effect of occurring the oscillations is known as Gibbs phenomenon. Gibbs phenomenon. Okay, now to avoid or to reduce this oscillation, the Fourier coefficient of the filter are modified by multiplying the infinite impulse response, that is HDN, with a finite weighing sequence, that is omega of n, weighing sequence, that is called window. So it is called window. So what is window? Window is basically a finite weighing sequence, finite duration weighing sequence, that should be multiplied with this infinite duration sequence to make it finite. Okay, now here is also this finite duration window sequence is also symmetric, so it should satisfy this property omega n equal to omega of minus n. Okay, so this is symmetric. Now this is not equal to 0 for mod of n less than equal to n minus 1 by 2 and equal to 0 for mod of n greater than n minus 1 by 2. So this is the window. Now there are several finite duration window. Among them, number 1 is rectangular window. Rectangular window. Now one thing is that how window is able to reduce this oscillation. Suppose there is a rectangular window here and it is filtered, or it just filtered this oscillation and it rejects the oscillation. Okay, so we can get a sharp ideal frequency response of the filter, okay, using this window. So there are various kinds of window. One is rectangular window. The form of rectangle, the expression of rectangular window, mathematical expression of rectangular window is omega r of n equal to 1 for minus n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2 equal to 0 otherwise. So rectangular window can be expressed by this expression. Another window is triangular or Bartlett window. Triangular or Bartlett window. So what is the expression for triangular or Bartlett window? That is omega t of n equal to 1 minus 2 mod of small n by capital N minus 1 for n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2. So this is the mathematical expression of triangular or Bartlett window. Now there is another window that is called raised cosine window. So number 3 is raised cosine window. Raised cosine window. Now raised cosine window can be mathematically expressed by this expression omega alpha of n equal to alpha plus 1 minus alpha cos 2 pi n by capital N minus 1 for n minus of n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2 equal to 0 otherwise. Okay, so this is rest cosine window. Now from rest cosine window we can define two kinds of window, that is number one is Hanning window. Hanning window. To define Hanning mathematical expression of Hanning window, that is omega h n of n, we have to assume the value of alpha is equal to 0.5. So it will be 0.5 plus 0.5 cos 2 pi n by n minus 1 for n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2 equal to 0 otherwise. Okay, so this is Hanning window. Now another kind of window, that is Hamming window. To get the mathematical expression of Hamming window, we have to assume alpha equal to 0.54. So the mathematical expression will be 0.54 plus 0.46 cos 2 pi n by n minus 1. If you put here alpha equal to 0.54, then you will get this expression. So for n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2 equal to 0 otherwise. Number 6 is Blackman window. What is the mathematical expression of Blackman window? That is omega capital B of n equal to 0.42 plus 0.5 cos 2 pi n by n minus 1 plus 0.08 cos 4 pi n by capital N minus 1 for n minus n minus 1 n minus 1 by 2 less than equal to n less than equal to n minus 1 by 2 equal to 0 otherwise. So you have to remember all the mathematical expression of all the windows, okay, to solve many mathematical problem. So what we learn from this video, we learn how to design the filter using window technique, and why we are using window technique to get the finite impulse response of the filter, and various kinds of mathematical expressions of various kinds of window. Okay.